Out at the edge of our solar system, sunlight takes over 5 hours to arrive. By the time it gets there, the sun doesn't even look like our sun anymore, just an unusually bright star hanging in a permanently black sky. That's where Pluto sits, nearly 3.7 billion miles away. For decades, scientists assumed they knew what they'd find there. A dead world, frozen solid, geologically finished billions of years ago. They were wrong. When NASA's New Horizons spacecraft made humanity's first, and so far only, close flyby of Pluto, it found mountains of solid water ice, glaciers made of frozen nitrogen, and entire regions of the surface that looked far too smooth, far too young, to make any sense on a world this old. Something down there has been quietly reshaping the landscape. And the strange part is, Pluto is supposed to be too small and too cold for that to even be possible. So what's actually keeping this frozen world alive? By the end of this journey, you'll understand exactly what's happening on Pluto's surface, and why its oversized companion moon is the reason we know any of it at all. Thanks for watching Nova Dread. Let's get into it. We discovered Pluto in 1930. We didn't actually see its surface for another 85 years, one mission. That's all we've ever had. New Horizons launched in 2006, spent 9.5 years crossing the solar system, and on July 14, 2015, raced past Pluto at nearly 31,000 miles an hour. It couldn't slow down, couldn't land, just a few hours to grab everything it could before vanishing into the dark. What it sent back changed the story completely. Instead of a battered, cratered relic, it found towering ice mountains, vast nitrogen glaciers, and one region so smooth it simply shouldn't exist. In a place that's absorbed impacts for over 4 billion years, almost no craters makes no sense, unless something keeps erasing them. Something was renewing Pluto's surface, and the biggest clue turned out to be hiding inside its most famous feature. Pluto's most famous feature is a massive heart-shaped region called Tombaugh Regio. It looks like a simple pattern on the ice. It's actually one of the most geologically active places we've found this far from the sun. The western lobe, Sputnik Planitia, is a smooth basin roughly 620 miles across, made almost entirely of frozen nitrogen. Here's the strange part. At Pluto's temperatures, that frozen nitrogen doesn't sit still. It behaves like thick honey. Slowly, almost imperceptibly, it flows. Scientists found the basin covered in giant cellular patterns, each around 20 to 30 miles wide. Not craters, not cracks, convection cells, the same basic process as water boiling in a pot. Warm nitrogen rises, cools at the surface, then sinks again, over and over, quietly wiping out impact scars as it goes. That's why this region looks so young. But convection needs one thing to keep running: heat. And Pluto barely gets any warmth from the sun at all, 1,600 times weaker than what Earth receives. So the obvious question is, where's the heat actually coming from? The answer might be sitting somewhere no one expected to find it, underneath the ice. For a long time, the idea sounded absurd. Pluto is smaller than our own moon, a body that size should have gone completely cold billions of years ago. But the evidence kept pointing the other way. Sputnik Planitia sits in a position that doesn't quite match Pluto's rotation, as if the outer shell has slowly shifted over millions of years. That kind of movement only makes sense if something underneath is letting the crust slide, like a layer of liquid acting as a lubricant. Then New Horizons spotted the fractures, ridges, terrain that looked stretched apart from below, right around the edges of that basin, and not far from there, massive structures rising several miles into the sky. At first glance, mountains. They probably aren't. They may be cryovolcanoes, ice volcanoes. Instead of molten rock, these would have erupted slushy mixtures of water and ammonia from deep inside Pluto. One, Right Mons, stands nearly 2.5 miles tall with a huge depression at its center, almost identical to a volcanic caldera on Earth. Nearby sits an even larger one, Picard Mons, and around both, almost no impact craters. In planetary science, that's the tell. Heavily cratered means old. Barely cratered means young. These ice volcanoes may have been active far more recently than anyone expected. If that's true, Pluto isn't just preserving its past. It might still be writing new chapters right now in total darkness, 6 billion kilometers from anyone watching. So how do you keep an ocean liquid on a world this cold for billions of years? The answer traces back to something buried deep in Pluto's core, and to a moon that's been quietly influencing this entire story. To understand Pluto, you have to go back to 1978 to an astronomer named James Christie, doing about the most tedious job imaginable, sorting old photographic plates of Pluto to refine its orbit. Several plates had already been thrown out, marked defective because instead of a clean dot of light, Pluto kept showing up smeared with a strange bulge on one side. Most people would have blamed the equipment. Christie didn't. He'd spent years studying double-star systems, and that bulge caught his attention. He checked the background stars on the same plates, perfectly sharp. If the telescope or atmosphere were the problem, everything would have been blurry, not just Pluto. That meant the bulge was real. He dug through the archive back to 1965 and tracked how it moved over time. It circled Pluto roughly every 6.5 days, matching Pluto's own rotation almost exactly. Pluto had a companion, a moon hiding in plain sight, locked in perfect sync. He named it Charon, partly after his wife, whose nickname was Char. Once Charon was confirmed, scientists could finally calculate Pluto's real mass, and the number was almost embarrassing. Pluto turned out to be barely a sixth the mass of our own moon. Charon, by comparison, was enormous, about 12% of Pluto's mass. Our moon is only around 1% of Earth's. Charon isn't a typical moon quietly circling its planet. It's close to being an equal. That changes the physics. Normally, a moon orbits a point buried deep inside its planet. Here, the two are close enough in size that their shared center of gravity sits in empty space between them, about 1,000 kilometers above Pluto's surface. Neither one is really orbiting the other. They're both circling a point that isn't really anywhere, and both worlds are locked so tightly that Charon always shows Pluto the same face, and Pluto always shows Charon the same face back. Stand on the right side of Pluto, and Charon just hangs there, motionless, forever. Stand on the other side, and you'd never even know it existed. It's part of why some scientists argue this isn't a planet and a moon at all. It's a double planet. And that idea helped light the fuse on the biggest argument in modern astronomy. By the early 2000s, astronomers kept finding more icy worlds past Neptune, Quaoar, Sedna, Makemake, than Eris, initially thought to be even bigger than Pluto. That created a real problem. If Pluto counted as a planet, so did Eris, and probably a dozen more objects waiting to be found. Something had to give. So in 2006, the International Astronomical Union set 3 rules. A planet must orbit the sun, must be massive enough to pull itself round, and this is the one that mattered, must have cleared its orbital neighborhood of other debris. Pluto passed the first 2 easily. It failed the third. Its orbit still overlaps with thousands of other Kuiper Belt objects, and it was never massive enough to clear them out. One rule. That's all it took to end a title Pluto had held for 76 years. And here's what still bothers a lot of scientists. Jupiter shares its orbit with over 100,000 Trojan asteroids. Nobody's proposing we demote Jupiter. The Pluto-Charon relationship wasn't officially why Pluto got demoted, but it was the data from that relationship, Pluto's tiny mass, its strange gravitational dance, that helped set the whole debate in motion. So how did 2 worlds this different end up bound together? The old theory sounded like how our own moon formed, a massive impact, debris flying into orbit, eventually clumping into Charon. Clean, simple, violent. Except Pluto and Charon aren't molten rock like early Earth. They're small, rigid, mostly ice. And ice doesn't behave the same way in a high-speed collision. It shatters instead of reforming. Instead of a violent collision, scientists now think the encounter may have been surprisingly gentle. They call it kiss and capture. The 2 proto-worlds grazed each other at low speed, briefly stuck together, spun as one lopsided object for a few hours, then slowly pulled apart again, staying gravitationally bound ever since. It explains why both worlds survived mostly intact and why Pluto is around 70% rock while Charon is closer to 55%. Meaning they never fully melted together. That same gentle collision, plus the tidal stretching as they separated, pumped a huge amount of heat, and at the North Pole sits a dark, reddish stain nicknamed Mordor Macula. The leading theory, methane escaping Pluto's thin atmosphere drifts across the gap, gets pulled in by Charon's gravity, freezes onto its pole during a century-long polar winter, and gets cooked by radiation into that deep red color. If that's true, Pluto has been quietly painting its own moon's surface for millions of years. So let's come back to where we started. Something is happening on Pluto's surface. Mountains rising, an ocean that shouldn't still be liquid, maybe even volcanoes still erupting in total darkness right now. And we only know any of this because of a smudged photograph nearly dismissed as a mistake in 1978. That mistake led to Charon. Charon gave us Pluto's real mass, and that data helped trigger the very vote that stripped Pluto of its planetary title 30 years later. Whatever label we put on it, one thing isn't up for debate anymore. Pluto isn't the dead, frozen leftover we assumed it was for so long. Something is still moving down there. So here's what I'm curious about. If Pluto is still alive down there after billions of years, what do you think we'll discover when humanity finally returns? Let me know in the comments. See you in the next video. Bye.